So, as you said, his presentation, I will just read actually mostly the theoretical part, and I will let you see the formulas yourself because I wouldn't dare to go there. So it's a theory on the unification of physics and the elimination of unbound quantities by Mr. Shpëtim Nazarko, who's an independent researcher from Albania. So, yeah. Here's an outline of the theory. Why am I struggling with this? I want to get rid of the gallery so I can just see my presentation. Anyway, so just an introduction. It's basically based on Descartes-Leibniz debate on transform of motion, and it's based on the expression of energy that allows transformation of the energy. So he comes with a definition of two energy components. And we will talk later about the use of a new formula of energy in the derivation of the equation of the motion. He will talk later about the special parameters associated with a certain object. So introducing a pair of space and time parameters. Derivation of the physical quantities, that's the second part. So it is well, just a second, just a second, please. No page that I just want to get the outline, to get rid of the outline so I can see the whole presentation. Ariel, can you help me with that, please? I'm still screen sharing. So as I was saying, yeah, it's okay now. It's më ndihmo pak me share screen të mos shoh pak këto video. So it is a well-known and permanently established in the history of physics, the Einstein's intervention to explain the deviation of the laws of mechanics at high speed. The solution required replacing Galilean transformations with Lorentz transformations. Theoretical physics never developed the fundamental question at the heart of the study. Just a second. Si mund ta shoh komplet këtë pa videon? Okay. Why? So the question is, why did the criticism and Einstein, in order to solve the crisis of the time arising from those experiments, why didn't they use the classical Lagrangian? That was the question he raises in his study. So, unlike the Galilean transformations, which were valid for inertial reference systems, the Lagrangian solving problems regardless of the reference system where events occur. So this powerful mechanism had a different character. So it was valuable not only for inertial systems, regardless of their form, but it had surpassed the significance of the Galilean transformations. It seems logical that the effort to solve the 1905 crisis should have been not the modification of time of the Galilean transformations, but the modification of the classical Lagrangian form. So the study's response thus views the impossibility of using the latter. In the studies Lagrangian, energy is seen as a constant quantity, which, under the action of force, transforms and does not change its quantitative value. The process is reflected by the Lorentz vector, which shows how it transforms, not how it changes. Energy is composed of two parts. The part that is exposed with speed and the unexposed part of the energy of the system and does not affect it by excuse just a second, please. Give me, I'm sure we will have more time than we need. I would appreciate if you just let me 1 minute to make sure that it's 1 second. Thank you very much for your flexibility. So I'm just going to open it on a different laptop so I can read it better. I'm so sorry, Mr. Nazarko, but I just want to make I just want to make sure that I get it correctly. Thank you very much for your Tedrilona. Anyway, in the meantime, so the energy is composed of two parts: the part that is exposed with speed and its unexposed part. By deriving the energy exposed with speed, we automatically obtain what Einstein's laws say for force and impulse. So the exposed energy in this case constitutes this field from which the laws of mechanics and the special theory are derived. The force derived from the energy itself is also found when the object is at rest, expressing still its inertial its minimum energetic state. In objects with a small mass, it is expressed by the classical radius, while in the larger ones, by the Schwarzschild radius. With speed, the force increases, showing also the reduction of the corresponding radius. At a length, it corresponds to that of Planck. The force derived from the object is maximal. By utilizing the law of distance from this point, we can find its value at any point we wish. Practically, we have achieved the unification of physics, which accepts that at Planck length, or expressed differently, at the dimension of Big Bang, are the same nature. They take different appearances after this distance. So this would be a unification of physics. So that was Descartes' Leibniz debate. I mean, this is just for you to know that the whole idea actually starts with this debate, Descartes' Leibniz. Descartes' thesis on the quantity of motion and Leibniz agreement on the thesis or statement, but not on the expedition. Leibniz proposed mass mv, you are the experts, you know this, mv square, as this could transform the motion. That was Leibniz's proposal. Leibniz was correct in terms of quality, but not quantity. So here are the 4 steps employed in this presentation, in this work. Energy is constant and independent of the object's speed or form of motion. A field can be associated with an object. Every object has a pair of space-time parameters with a quantum character. Using these space-time parameters, we calculate all the parameters of an object, including the field that the object inherently possesses. And from this field, we can calculate its force. So let's see the energy associated with a certain object. So we have the total energy. Yes, this is Einstein's energy, you know, the energy of an object at rest. And out of this total energy, we have the exposed energy. And here's the formula. Actually, the exposed energy would be the new transformed Lagrangian, if you like, based on energy. So out of the total energy, we have the exposed energy, the new Lagrangian, and we have the unexposed energy. And then every object has an internal energy and an external energy. And the sum of both of them equals square MC. Yeah? So the unexposed energy, Mr. Nazarko says, is the energy which we usually refer to as the dark energy, the missing energy in the universe. So it's an energy that does exist, of course, but it does not affect the system. That's why we do not measure it. What we actually measure is the exposed energy only. Okay? So let's move on. The exposed and unexposed energy. So we have the exposed energy. I think we had this already. Okay, so we have the exposed and unexposed energy. So the exposed energy has a kinetic character. It is experimentally measurable. Okay, and let's see the unexposed energy. It has a potential character. It is an internal energy. The unexposed energy is not experimentally measurable. That is exactly why we do not measure the unexposed energy in the universe. Okay, so here we have. So this is what Newton says. What happens to an object? An object may go to infinite space, right? Because of its force. And here we have Einstein's theory. So according to Einstein, on the other hand, an object can never achieve light speed. Okay. And this is the third. This is your model. So this is Mr. Nazarko's model, according to which the sum of both unexposed and exposed energy remains constant all the time. This would be the essential, distinction or difference between his model and the two other existing models, Newton's and Einstein's. So this picture represents the domain of all the physical theories. Everything occurs within limits. This is a new diagram, the one we just showed you, based on this formula. A formula which shows basically that energy remains constant and that it does not depend on speed, even if it is light speed. So energy remains constant. And when it reaches that speed, it still remains constant. It just transforms itself. So in other words, the whole question is, should we change maybe the paradigm, Should we still refer to speed only, which is an inferior, let's say, measurement or dimension, or should we rather refer to energy? This is the essential, novelty, let's say, of this model. This is the main difference between Mr. Nazarko's model and the Einstein, when he built his own theory, he was not aware yet of the energy as a dimension, so he based his theory on speed only.
Por zgjidhja e tij, që ishte shumë e saktë nga pikpamje kuantitative, la prap problemin kryesor që zgjidhja ishte vetëm për sistemet inerciale.
So his solution, which was quite good, in terms of quantity, was still missing out on something. It was missing out on the inertial systems.
He
did try for 10 years to correct that, actually, with his general theory. But his theory, again, after 10 years, was still limited, regardless of quantitative achievements.
Ai mendoi, thuaj që është lakimi I hapësirë kohës, ai që mund të përjashtonte sistemin ose përfaqësonte sistemin e vjetër newtonian.
So Einstein believed that it would be this system of time and speed that would represent, let's say, Newton's, excluding force, though, from the equation.
Hapësira dhe koha janë mjete matje.
Space and time, though, are measurement elements.
Të cilat kurba grafike të cilave duhet përputhet gjithnjë me kurbën e ligjit të ruajtjes së energjisë.
But the curve of space and time should actually always equal the curve for the laws for the preservation of energy.
Ligjin e ruajtjes së energjisë, që Einstein nuk e kishte dhe për këtë arsye ai zgjodhi.
So Einstein did not yet have the law for the preservation of energy.
Për të gjitha sistemet inerciale,
për të gjitha sistemet referimit. For all the reference systems. So
zgjidhja e tij ishte e limituar dhe kësaj radhe.
So that is why Einstein's solution, even after 10 years of work, was still limited. It was missing out on this energy preservation laws.
Ai vazhdoi thuaj 50 vjet për të kërkuar të unifikonte gravitacionin me elektromagnetizmin.
Einstein did try for 50 more years to equalize, like to unify electromagnetism and gravitation, but he could not do it.
Sepse pikpamja e tij fillestare e bazuar me shpejtësinë e dritës dhe
So,
jo mbi energji.
he could not do it because he was always referring to light speed and not energy.
Ndikoi në mosgjidhjen e problemit.
So that is what limited him, let's say.
Duke u bazuar mbi energjinë, dhe me Lagrangianin e bazuar mbi energjinë.
So if we refer to energy, and if we use this, let's say, a new updated Lagrangian, which is based on energy,
Ne mund të nxjerrim lehtësisht siç shikohet më poshtë.
so we may now easily, as I will show you below, we may look back at both Newton's and Einstein's laws using now the new Lagrangian. Let me show you. So the new model, it says, can derive the equations of motion for, okay. So this is the Lagrangian. So the exposed energy used in the Lagrangian formalism is bounded and it does not diverge to infinity. So we would exclude the infinity also, you know, from the game, let's say. So it transforms through the Lorentz factor. I wouldn't be able to read the formula, but you can see it. So we can derive the equations of motion for the classical and relativistic theory. You've got the formula again. So this is the correlation, let's say, of special parameters, space parameters and energy.
Ja Lagrangiani I thuaj mësojmë që forca derivohet është një derivat I dytë I energjisë.
So from the new Lagrangian, we see that force is a second derivative of energy.
Që do thotë që ajo është një karakteristikë po inerente e objektit si vetë energjia.
Which means this is again an inherent inherent, you know, character.
Kjo tregon një diferencë tjetër nga mënyra se si e filluam ne ndërtimin e fizikës tonë.
This again brings us to a different perspective of how you start physics.
Newtoni u detyrua duke mos e njohur energjinë, ashtu si dhe Einsteini në fillim të teorisë speciale.
So this leads us to how Newton and Einstein, you know, build their own laws. Not recognizing energy back then.
Menduan që me anë të forcës mund të rrisnin energjinë.
I mean, they did not calculate, they did not factor it in. So they thought that without the energy, they thought they could increase energy through force.
Pa e ditur që forca ishte vetëm një mjet I cili shërben vetëm për transformuar energjinë.
Not knowing yet that force actually serves to just transform energy.
Kjo u vu re qartë në debatin e famshëm Descartes Leibniz që vazhdoi për 200 vjet dhe për 100 vjet dhe ndau gjithë kampin e Evropës në dy.
So this is what you could see, you know, easily in the Descartes-Leibniz debate for 100 years, which even divided, let's say, European scientists and physicists into two camps, including even Kampf and Hegel. Okay. So the fact that force is a second derivative of energy. So with force being the second derivative of energy, we can also see it in Colombo law. Can I?
Duhet përshkruar tani nëpërmjet konceptit energjisë dhe jo nëpërmjet konceptit forcës.
So again, we should, let's say, rewrite Columbus law using the concept of energy and not force.
Të njëjtën gjë duhet themi edhe për ligjin e gravitacionit Newtonit.
And we could say the same about Newton's gravity law.
Pra ligjet e vjetra thuhet duhen përshkruar nëpërmjet konceptit të energjisë dhe nëpërmjet konceptit të forcës.
So we need to look at these existing laws by now factoring in, the concept of energy and force.
Forca të një objekt thuhet derivohet dhe kur ai është në qetësi.
Force derives from an object even when the object is at rest.
Tek ligji i Kulombit ne mund ta shikojmë thuaj që ajo përfaqësohet nga ajo që quajmë rreze klasike e elektronit.
So we could see this in Columbus' law in what we see the classical radius of the electrons classic radius.
Në trupat me masa të mëdha ne e shikojmë rrezen e qetësisë të barabartë me atë që e quajmë rreze Schwarzschildi.
So we can see this radius of force of an object when they are in a large mass. We can see this in what we call the Schwarzschild radius. Okay?
Ky koncept ndryshon nga koncepti I përgjithshëm që I jep kuptim tjetër rrezës Schwarzschildit.
And this is a different concept from the classic concept of Schwarzschild radius.
Këto dy rreze tregojnë gjendjen minimale energjetike të objektit në qetësi.
These two radii or radiuses, they show the level of energy of an object at rest. That is the minimum inherent energy. Okay, we go further with the. So you talked about the electrostatic energy. Boltzmann constant, which equals 1.
Dhe duke paraqitur në këtë lloj forme ligjin e Kulombit thoj.
So this would be Columbus' law, updated in a way.
Duke pjesëtuar dy anë të ekuacionit me shpejtësinë e dritës.
If we would divide both sides of the equation by the light speed,
ne marrim një ekuacion tjetër.
We get a new equation.
I cili
This new equation,
I cili është I barabartë duke pjesëtuar e-n katror me c, ne marrim ekuacionin AH.
So by dividing square E by C, we get AH.
Ku A-ja thoj, alfa, është konstantja e strukturës Holt-Sommerfeldi dhe H-i
so where
e Planckut.
Alpha would be
Sommerfeldi.
The Sommerfeld constant and
Planckut.
H would be the Planck's constant.
Shtu ekuacioni merr trajtën përfundimtare.
So the equation now is finalized. Oops, sorry.
Ky është ekuacioni përfundimtar.
So this would be the final equation.
I cili si shikohet është I përbërë vetëm nga konstante.
So as you see, this new equation consists of constants only.
Dhe I vetmi faktor që ndryshon është rrezja R-ja.
The only factor that changes is the radius.
Në qoftë se elektroni është në qetësi, ai ka atë që quajmë rreze klasike.
So if an electron is at rest, it has what we call the classic radius.
Në qoftë se elektronin do ta vëmë në shpejtësi, rrezja e elektronit ndryshon duke u shkurtuar.
If the electron gets some speed, the radius changes by getting shorter.
Por ndërkohë rritet dhe impulsi mc.
But the impulse mc increases at the same time.
Dhe ky ekuacion ka gjithë një trajtën konstante sepse rritja e impulsit çon në shkurtimin e rrezës.
So it still remains constant all the time because you have the impulse increasing on one hand and the radius getting shorter on the other.
Me shpejtësinë, pra ne kemi zvogëlimin e parametrave të rrezës.
So with speed we have the radius getting shorter.
Por duke thyer kurbës që jep do të dy energjit.
But if we go back to that chart with the two energies crossing,
Pikën ku ato kryqëzohen janë të barabarta,
so
energji ekspozuar.
When they cross the exposed energy and then unexposed energy, so when they become equal,
Kjo pikë është 0.86.
This point where they meet is 0.86, 0.86 of the light speed.
Pas kësaj, të gjitha fenomenet janë të karakterit kuantik.
So after that, so once we reach that point, anything that happens after that is of a quantic character.
Pra, parametrat hapësinor dhe kohor janë të karakterit kuantik,
So
virtual.
The space and time parameters are now virtual parameters. They are of a quantic character.
Në përgjithësi të gjitha teoritë klasike e Einsteinit, e Maxwellit.
So all the classic theories like Einstein and Maxwell,
Teoria e përgjithshme dhe teoria e Maxwellit,
the general theory and Maxwell theory,
mbarojnë kanë efektivitet deri në 0.86.
So these theories, these classic theories, they only work until we get to this point. When the speed gets to 0.86% of the light speed. And after that, anything we measure needs to be measured by the quantic mechanics, which is, after all, the mother, let's say, of all theories.
Dhe këtu duhet bëjmë një shpjegim në momentin që ne jemi ndeshur me ligjet fillestare të natyrës.
And here's where I need to make an explanation. So once I see the initial theories of nature,
ne kemi parë projeksionet e ligjeve më të komplikuara.
We do see, so in the simple, laws of nature, we do see projections of the most complex theories.
Dhe kemi dashur pastaj që nëpërmjet këtyre projeksioneve të gjejmë origjinën e ligjeve të komplikuara.
So, through the reflection of these complex laws, I was looking, for finding the origin of those complex laws.
Ky proces është I lidhur me një vështirësi që mund ta shpjegojmë kështu. Ne kemi parë hijen që lëshojnë gjethet e një peme dhe nëpërmjet hijes që është një madhësi e vazhduar kemi kërkuar të ngjitemi të shikojmë.
Let me put it in other words. So what we have seen so far is the shadow of the leaves of a tree. What I'm trying to do is try to find the origin of that shadow, which is a continuum.
Mund ta themi akoma më thjesht shembullin. Ne njohim në praktik mbesën thuaj, por jo gjyshen e saj.
Let me put it even in a more, let's say, a colloquial context. So we may know a granddaughter, but we don't know her grandmother. We may know a young girl, but we don't know her grandmother.
Normalisht, eksperienca duhet na mësojë që të fillojmë kërkimin nga lart poshtë, pra, të ndërtojmë ligjet me bazën e energjisë dhe me anë të forcës.
So experience should tell us or teach us to find things like top down, start from energy and not force.
Duke vazhduar thuaj me ekuacionin MCR baras me konstantën.
So by referring still to this equation, MCR equals constant.
Ne mund të arrijmë që duke zvogluar rrezën të shkojmë deri tek ajo që quhet gjatësia e Planckut.
So by keeping reducing the radius, we could reach what is called Planck's length. And radius and time should be associated with the energy state of an object. An object can have its lowest and highest energy state.
Energjia minimale përcaktohet nga rrezi I Schwarzschildit.
So the minimum energy is determined by the Schwarzschild
ose rrezja klasike.
Or the classic radius.
Dhe rrezja minimale përcaktohet nga gjatësia e Planckut.
The minimum radius is determined by Planck's length. Okay? Parametrat hapësirës. So the ready have a quantum character, which we mentioned earlier. They are not experimentally measurable because they're virtual, you know, they have this quantum and virtual character. So that's why they are not experimentally measurable. And sometimes values may match the values experimentally measured. And this might lead us to relatively wrong conclusions. At some critical mass, radii expression changes. Okay. This critical mass is what we in practice call the Planck's mass. Just showing you. I'm sure you can follow. Okay. He's skipping it for me because it would be very difficult for me to follow. So here I have shown how you can calculate the radius for masses that are smaller or larger than Planck's mass. Okay? This shows how they keep increasing. Sorry. So the table again shows us how you can calculate the ready by using this formula. And let me give you just one example. The electron's minimum radius, that is where force is maximal, so it is equal actually to what is known as the Schwarzschild's radius, the general theory. So this radius, which is actually 10 in minus 57, this is actually a virtual radius, a virtual radius of a quantum character. However, the force the object derives itself is maximum. So what's the key? What's the secret here? So when an electron, when his radius changes from 10 in the power of minus 57 to 10 57 meters, what happens to the electron is that its force increases. So the force that the electron itself derives, and this happens just because of this change in the radius from the initial length to the maximum length.
Dhe forca në këtë rast, kur bëhet ky raporti I forcës maksimale me atë minimale, është I barabartë me raportin e rrezeve.
So the correlation between the maximum and minimum force is equals the correlation between the maximum and minimum radius.
Dhe kjo është një raport që është afërsisht 10 në fuqi të 42.
So this correlation is about 10 in the power of 42.
Por ne dim nga ligji I inversit të katrorit me distancën.
But we do know from the inverse law of a square and distance
që në qoftë se forca është 10 në fuqi të 42, rrezja reale do të shkurtohet me një madhësi që është rrënja katrore e kësaj.
So we know already from this law that if the force is 10 in the power of 42, the radius would be like the square of, which you see here on the formula also. Yes?
Dhe pikërisht në këtë moment, elektroni e shkurton rrezën e vet klasike.
So what happens with the electron is that the radius gets shorter to the classic, length, which is the square of the square of the correlation between the maximum and minimum force. So practically, the real minimum radius of the electron so it equals Planck's minimum radius in nature, the natural minimum radius. So any object, regardless of its mass, so when the object reaches Planck's length, regardless of its mass, the object still generates maximum force.
Pikërisht në këtë pikë ne mendojmë që forcat e natyrës janë të njëjta, kanë natyrë të njëjtë.
It is exactly at this point where I think that the forces of nature are the same. They have the same nature, the same character.
Dhe ne mund ta gjejmë këtë forcë kudo që dëshirojmë duke përdorur ligjin e inversit të.
And we may be able to find that force in any object by using this law, the inverse law of a square and distance.
Kjo do të thotë që forcat e natyrave të ndryshme.
So this means that the forces of different nature
na duken të tilla për shkak të dëndësisë që ka objekti ose forcës që derivon ai në çdo moment.
So this takes us to the perception, to how we perceive different forces, and this is because it is affected by the density of an object and the nature of their force.
Tu ne kemi llogaritur se si gjendet kjo gjatësi.
So this is how we calculate, how you find the minimum real radius of every object.
Pra kjo është e barabartë me rrjedhën katrore të rrezës maksimale, rrezën minimale pjesëtim për 2.
So the real length of the radius of an object would be the square of the maximum radius, minimum radius divided by 2.
Numri 2 thuaj tregon se llogaritja duhet fillojnë.
So this number 2 shows that our calculations should start.
Atje ku energjia ekspozuar bëhet e barabartë me të pa ekspozuar.
So this number 2 shows us that our calculation should start from the moment that the unexposed energy equals the exposed energy.
Sepse pas kësaj pike thuaj të gjithë parametrat që llogarisim janë të karakterit kuantik por virtual.
Because once we go beyond that point, whatever measurements we make are of a quantum character, of a virtual character.
Lera e gjetur.
So then the value we come up with,
Kjo vlerë e gjetur është analoge me gjatësinë e Planckut.
So this value we come up with is analog to Planck's length.
Por ka një diferencë prej tij.
But there's a difference between this one and Planck's length. And this difference is because this value takes into consideration the Sommerfeld's constant.
Plancku vet nuk e kishte këtë konstante kur bëri tabelën e vet.
Planck did not have this constant when he came up with his table.
Sepse tabela e tij e konstanteve u konstruktuar në vitin 1906.
Because his table of constants was developed in 1906.
Dhe Sommerfeldi e paraqiti konstantën e vet në 1916.
While Sommerfeld introduced his constant in 1916. So,
kjo paraqitje është shumë e rëndësishme sepse tregon një diferencë midis paraqitjeve të modelit të Schrödingerit ose të de Broglie't, të cilët bazohen mbi konstantën e Planckut, që është kuanti i veprimit.
So this difference is very important because it shows previous theory Schrödinger or de Broglie,
të cilët në qetësi I japin objektit gjatësinë infinit.
So according to them, according to theory, an object's radius at rest is infinity.
Dhe në shpejtësinë e dritës japin sa?
While
Japin zero gjatësi.
when the object reaches the light speed, they say that their radius is zero.
Duke shpjeguar procesin me produktin A her H, pra konstante Sommerfeld her konstante Planckut.
So by explaining this process, referring to Sommerfeld's constant and Planck's constant, we no longer talk about the quantum of action, we talk about a state of rest of an object. So this way, we also eliminate the infinity dimension.
Kjo vendosje e AH-s të imponon të korrektosh dhe principin e Heisenbergut.
So using these two constants, the Sommerfeld's constant and Planck's constant, it also allows us to even correct Heisenberg's principle.
Sepse tek principi Heisenbergut, ne mund pranojmë vlera arbitrare të dx-it.
Because
të plotësojmë kushtin e tij.
In Heisenberg's principle, we may accept arbitrary values of dx as long as it meets his, let's say, condition, which is the length of the radius.
Kur ndërkohë natyra na thot që gjatësia më e vogël është ajo e Planckut.
Nature, however, tells us that the shortest length is the Planck's length.
Në përgjithësi të gjitha teoritë duhen korrektuar në bazë të konstantës së Sommerfeldit.
Actually, in general, all theories need to be corrected by factoring in Sommerfeld's constant. Zgjata më shumë se ç'duaj.
E qartë, dakor. Do të thonë, duke përfunduar këtë, mund të themi këtë gjë që paradigma e fizikës e ndërtuar në këtë është jo mbi shpejtësinë e dritës, por mbi energjinë që qëndron konstante.
So, let me conclude by saying that the essence of all this is that we need to refer not to the light speed, but to energy, which remains constant.
Kjo na ndihmon të eliminojmë madhësitë e pafundme, jo vetëm tek energjia, por edhe tek impulsi dhe forca.
And this would help us eliminate the infinity as a measure in terms of impulse and force.
Njëkohësisht të kuptojmë që mjetet tona të matjes janë të sakta kur ato përshkruajnë mënyrën se si ndryshon energjia e objektit.
And this also helps us realize that our measurements would be accurate if they manage to factor in the energy of an object.
Ne kemi reformuar gjithnjë konceptet e kohë hapësirës.
So humanity has kept reforming the concepts of time and space.
Reformimi I tyre mbaron kur ne të kemi në dorë ligjin përfundimtar të ruajtjes së energjisë së
But
objektit.
we will only be done, with this reform once we have a final form for this law for the preservation of energy.
Dhe ky ligj duhet bazohet me faktin që energjia është konstante dhe transformohet.
And this law needs to be based on the fact that energy is constant and it transforms itself. So that was it from Mr. Nazarko. Thank you for listening to us. Sorry for the small technical glitches. Thank you, Mr. Sikandar. I can see you following us, and that's quite encouraging. At least we can see you. I'm sure everyone else is, but it's nice to have a face. Po I them faleminderit për që na dëgjuat, edhe po I them atij faleminderit që po na dëgjoni ju, sepse është edhe inkurajuese kur shef edhe një fytyrë domethënë që na shef. So thank you.